Good morning, students. Today I'm going to deliver you my lecture on routing. Basically, routing is a function of network layer. As we know that when packets deliver from outside the LAN to another network, then there must be destination address, and this address is identify the router, and router search for the optimal path from source to destinations. Basically, if we talk about routing, we can say it's a process of finding the optimal path from source to destinations in a network. Suppose you want to connect to Antarctica from your desktop, then there will be so many questions in your mind, like what's what route you should take, and does the any other shorter route exist? If the link along the router goes down, it means the router is down. Then what will be the solution to this problem? If we are using a mobile device that is moving its location from one place to another place, then what will be the route to send the packets? These kind of issues are deals in the routing and in routing algorithms. Before moving forward, we have to know what are the some basics about the routing protocols. First, we have to understand the what kind of data is stored inside the router's memory. So the data structure that is stored in the router's memory is called table, routing table, or this table can have multiple columns, and inside the columns they can be information like destination IP address, the next router to the output port, or the cost to the next router. So here in this table you can see destination 1 2 3 4 5. So these are not actual destination. Actually, for simplification, we put the destination IP address as 1 2 3 4 5. So to understand the situation, because IP address will take more space, so for simplification we put the destination as 1 2 3 4 5. Now the next line says the router makes local choice on a global topology. This is a fundamental problem. Why this is called fundamental problem? Because every router maintains a table, and this table contains the route to its neighbors. So it it make the decision for local choice. It means it sends the packet to the nearby router, but it must store the global topology. And this is the main problem of a router: how to store the global topology, because there may be so many changes in the global topology. A router may be down or a new router may be added to the network every time. There there are some kinds of issues are there. Now we will see what are the fundamental or what are the key problem with the local decision. First, uh, the first problem arise that on what basis the router must take decision about the global state. How it would know about the global topology? Because there are so many routers, thousands of router, lakhs of router in the world, and these routers are dynamic in nature because their table is changing after some moment, or there is a change or some timer expires. So it is very hard to collect the information about the global topology. So the routing protocol must handle these kinds of problems, and it must store the relevant information inside the routers. Now we will see that what is the requirement of a routing algorithm, or what we expect from a good routing algorithm. First point says that it must be stored with minimum space. It means the router required to store the information in very less space. The memory must be minimum, and its processing must be fast to look up the table and to find the global topology. There must be minimum number of exchange of message between routers, and there must be minimum number of frequency of control messages. Control messages are used to solve the problem inside the routers, whether router is down, router is up. There are so many query and response message. Those are implemented in ICMP protocol, that is known as Internet Control Message Protocol. They must be minimum. The another requirement says robustness. Robustness means if a router is on, then it is expected that it will work for a long future, or it must be avoid the black holes. Black hole means it in future it will not go down, or every it will not observe each packet. Number two, there must be no loops. Loop means if a packet is going from one outgoing port, and if it is coming revert back to the same router, then this problem is called looping problem. And third one is called the oscillation, in which a packet is oscillating between two or three routers. This is called oscillation problem. And the last requirement of a routing algorithm is called it must use the minimum or optimal path. Now we have some choices that what kind of routing algorithms are available in the market or in routers. The very first is called in the intra-domain or inter-domain routing, centralized versus distributed routing, source based or hop by hop, single versus multiple path routing, state dependent versus state independent routing. In next video we will understand these kinds of choices or routing algorithms.